All right, so welcome to the video on determinants, identity, and inverses of matrices. So first off, let's get our brains working here and remind ourselves of what an inverse is. So an inverse will take something and bring it back to the identity. So think about real numbers first. What is the additive inverse of 7? So remember, additive identity is 0, right? So that's what we learned in the past notes, or we talked about it in the past notes. I didn't say we learned it then. So what would I add to 7 to give me 0, which is -7, right? So the additive inverse of 7 is -7 because I would have to add -7 to 7 to get the identity, which is 0. What is here's that word. I swear I practiced before I started this video. Multiplicative. Oh, I did it. Multiplicative inverse of 7. So remember, the multiplicative identity is 1. So what do I multiply 7 by to get 1? It's reciprocal, right? So it's 1/7. Once again, the reason why is because 7 times 1/7 gives me that 1. So what is the additive inverse of x? -x. And what is the multiplicative inverse of x? 1/x. Okay. With functions, the identity is x. So once again, with addition, the identity is 0. With multiplication, the identity is 1. With functions, the identity is x. So let f of x equal this. What is f inverse? So let's find the inverse. Remember to find the inverse, which we've done multiple times before. Switch x and y, and then solve for y. So subtract 7 from both sides, and then divide by 3. I'm not going to put y equals. I'm going to put f inverse equals x minus 7 all over 3. And yes, you could divide both of those by 3 and have 1/3 x minus 7/3, but unnecessary. Okay, what would you get if you composed f of f inverse? So take f inverse and plug it into f, and then take f and plug it into f inverse. All right, so we have talked about this before. If you take f of f inverse, you should get the identity, and vice versa. Otherwise, they're not inverses of each other. So let's just show that that's true. We're going to take f, and we're going to plug in f inverse. All right, so take this right here and plug it into f for x right there. So we're going to do 3 times, and then plugging in x minus 7 over 3 plus 7. Okay, now we're going to simplify this. You do have to show your steps of simplification. You're going to say that 3 divided by 3 simplifies to 1. Then you have x minus 7 plus 7, and -7 and 7 cancel out. You just get x. And then f inverse of f. So we're going to take f inverse, and we are going to plug in f of x, which was 3x plus 7. Yes. So remember what this means to do. We are going to take this and plug it into the inverse for x. So we're going to plug it in right there. So we have equal sign 3 minus 7, and then we're plugging in 3x plus 7 for x. Okay. Simplify this in the correct order, in the correct steps. So 7 minus, I don't know why I did it in blue again. I want a different color. 7 and -7 make 0. So now you have, and you can't just cross off the 3's now, otherwise it's not showing what you did first. Now you have 3x divided by 3, and the 3 over 3 is equivalent to 1, so we have 1 times x, which is x. So, truth, that works, okay? All right, now let's get on to the topic of the day, matrices, the topic of the chapter, I should say. Here it says inverses with matrices are more difficult to find than with regular numbers. So, but the idea is the same. So you basically want to say, what do I multiply a matrix by to get the identity? Or sorry, yes, what do I have to multiply the matrix by to get the identity? So, and we know what the identity looks like from the next sets of notes. So these two are inverses of each other, okay? They are. And we're going to show that they're inverses of each other by multiplying them and show that I guess that's what you're supposed to notice, but we're going to multiply these to show that you do get the identity matrix. So let's go ahead and do that real quick. And the same thing with the next one, okay? We are going to multiply this by hand, okay? So we're a 2 by 2 times a 2 by 2 is a 2 by 2. And then we have row times row, so that's -1 times 1 is -1. 2 times 1 is 2. Then we'll do row 1 times column 2. -1 times -2 is 2. 2 times -1 is -1. Row 2 times column 1, -1 plus 1. And row 2 times column 2. 2 minus 1. Okay. Oh, and I made a mistake. Looky at that. It's the pink one. -1 times -2 is 2. 2 times -1 is 2. And I knew I said they were inverses of each other, and I didn't get 0 there. So I should have known. But hey, at least I figured it out. All right, so that is 1, 0, 0, 1. Voila. So these are inverses of each other. And then we're going to try to look at it and say, how the heck do we go from this to this? Like, what happened here? Okay, we'll do that in a moment. All right, here, oh my goodness, a 3 by 3 times a 3 by 3 is going to give me a 3 by 3. Okay, so I can do this. I'm feeling very confident. Row 1 times column 1. All right, 1 times -2 is -2. -1 times -3 is 3. 0 times anything is 0. That gave me a 1. I know I did it right. All right, row 1 times column 2. 1 times -3 is -3. -1 times -3 is +3, and 0 times anything is 0. That gave me a 0. I'm doing good. Row 1 times column 3. So 1 times 1 is 1. -1 times 1 is -1. 0 times anything is 0. Wow, I'm just so smart right now. Okay, now I'm on to row 2. Column 1. 1 times -2 is -2. I got 0 and 2. I almost tried to speed through that, and I almost messed up. Okay. Row 2 times column 2, that's -3 plus 0 plus 4. Row 2 times column 3, that's 1 plus 0 minus 1. All right, last one. I can do this. All right, 6 times -2 is -12. -2 times -3 is 6. -3 times -2 is 6. All right. 6 times -3 is -18. -2 times -3 is 6. -3 times -4 is 12. And then lastly, we have 6, -2, -3. Yay. Okay, clean that up. And we should get an identity matrix, otherwise it's not the inverse. Otherwise I messed up, let's be serious. All right, so that's 1, that's 0, that's 0. So far, so good. 0, 1, 0, still doing great. 0, 0, 1. Yes. Okay, I know, I still get excited about doing things right. All right, so we have to try to figure out, you can try to figure out how I go from this to this. You should see some similarities, okay? But we can't assume those things because now when we look at a 3 by 3, how do I go from this to this, okay? A little side note as you're thinking about that, the matrix I is what we use for identity matrix. So this is I equals, well, it's not, that is the identity matrix. This is the identity matrix. I was gonna say up there it is, but that was on the last notes. And it's equivalent. It gives you the same thing as multiplying by a scalar of 1 when you're multiplying. So if I were to multiply by a scalar of 1, it's the same thing as multiplying by the identity. Okay. All right. So before I show you how to find the inverse of a matrix by hand, you first have to know what a determinant is, okay? A determinant, you can only find the inverse of a square matrix, 2 by 2, 3 by 3, 4 by 4. And you can only find the inverse of that, you can only find the determinant of that, okay? So if you have a 2 by 2, we're gonna start with that by hand, okay? You could be asked for the determinant like this. DET means find the determinant of that matrix, A, B, C, D. Or it'll just have these bars on it, and that also means find the determinant, okay? So this says evaluate the determinant of that matrix. So it doesn't, I don't have the formula here for some reason, but I'll give it to you right now, okay? To find the determinant, what you're gonna do is you're gonna multiply these two values, A times D, and then you're gonna multiply these two values, B times C, and you're gonna subtract those two values. So A times D minus B times C, and it has to be in that order. It has to be the 1-1 entry diagonal first. Okay, this only works for a 2 by 2, but that's it. But you need to know how to do this in order to find the inverse. So let's do some nice 2 easy ones here. To get this, we're gonna multiply 1 times 5, which is 5, and subtract 2 times 3, which is 6. So the determinant is -1. Here this says evaluate the determinant. 5 times -1 is -5, minus -2 times 6 is a -12. That is 7. So the determinant there is 7. Notice the answer, notice the determinant does not have to be a positive number. It can be a negative number, but it can't. Well, it can be 0, but I shouldn't say it can't be 0. It can be 0, but we'll talk about how that affects the inverse in a moment. All right, so next, let's look at the determinant of a 3 by 3 matrix. So these are called third order determinants, and they can be evaluated using the diagonal rule. So these are the steps right here. So if you have a matrix A, B, C, D, E, F, G, H, I, so this written as a matrix, that just says find the determinant of, but if 9 entries, right? A, B, C, D, E, F, G, H, I, 3 by 3. What you're gonna do to find the determinant is you're gonna write the first 2 columns. I should probably color coordinate this. You're gonna take this column and write it to the right of the third column. And then you're gonna take the second column and write it to the right of that. Okay, so that's what you're gonna do. You're gonna rewrite the first 2 columns to the right of the determinant. And then you're gonna draw diagonals or circle the diagonals. It's up to you. Let me get my highlights out of here. So what you're gonna do is you are gonna multiply these 3 entries, A times E times I, multiply these 3 entries, B times F times G, C times D times H, okay? And then you're gonna multiply these 3 entries, and these 3 entries, and what you're gonna do is you're gonna sum the first 3, sum the second 3, and then subtract those 2 sums. Yeah? It's not difficult. It's like one of those things that if you know what to do, it's not bad, okay? So, notice that I have a 3 by 3 matrix. It's not even written in the matrix formula. It is made up of rows and columns of entries, but remember the double lines means find the determinant. So to find the determinant, what you're gonna do of a 3 by 3 is you're gonna copy down the first 2 columns, 4, 1, 2, and 2, 1, -3, okay? And then you are going to multiply, starting with 1, 1, okay? Starting with 1, 1 here, and you're gonna go on a diagonal. So you're gonna multiply these 3, and these 3. So you want to make sure your handwriting is not too sloppy too. All right. So 4 times 1 times 5 is 20, and you're going to add to that 2 times 0 times 2, which is 0, and you're going to add to that -1 times 1 times -3, which is 3. Okay, you're going to take that number, which is 23, and you're going to subtract from it the sum of the other 3. Okay, so the other 3 that you are doing, okay, is if you want to go from this direction, you can, to know that you're going in the upper right-hand corner so you don't accidentally take the wrong ones, but it's the third one from the right you're starting in. Like the third one from the right is where you're starting at and going down into the left. However you want to do it, okay? All right, so those numbers are 2 times 1 times -2, which is -2. -3 times 0 times whatever is 0. 5 times 1 times 2 is 10, so this is 8. So we have 15 as the determinant. Why don't you go ahead and pause the video and try the next one. You should have 0, 4, -2, 0, 12, 8. I'm gonna multiply these 3, and these 3. So I have 0 plus 0, and it's gonna say show your work every time so I know where your numbers came from, okay? 0 plus 0 plus 32. So 32 minus. And then going in the other direction, this, and this. So we have negative 24 plus 8, squinting, sorry, my eyesight is not that great, plus 4. So that is, no, that's a 0, I swear. That could have been bad. And the other one's a 0 too. Oh my God, 8 times 1 times 0 is 0. Holy moly, that could have been bad. Okay, I swear I know how to do math. All right, so that is actually plus 24 because it's minus a negative 24, which is 56. And I can use my calculator to check. Ooh, that's pretty, I'm keeping it. Okay, but I'm good. All right, so why did we just do the determinant? Because now we're gonna learn how to find the inverse. Okay, so we talked about inverses of a matrix when we started this, and we said that these two, where'd you go? These two are inverses of each other. These two have inverses of each other, but I didn't show you how to do that. So let's go ahead and see how to do that. The inverse of a square matrix, so it says in scalar algebra, we know that A times 1 over A is equal to A because A and 1 over A are inverses of each other. No, they're not. Well, yes, they are. But that's the identity too, right? And then, oh my God, I can't read this. A times A inverse is equal, okay, A times A inverse is equal to A inverse times A, all right? That's true. And both of those are equal to 1. Yes, all of these are equal to 1. That, and that's equal to 1. I don't like how that's written, but it's okay. Also, A can't be 0, otherwise it's undefined. We call A to the negative first power the multiplicative, I did it, inverse of A, okay? For square matrices, we define the inverse, capital A inverse, as having the property that A times A inverse, or A inverse times A, is always gonna give you I, which remember is an identity matrix. So if it's a 3 by 3, 2 by 2, 4 by 4, whatever, it's the ones on the diagonal from upper left to bottom right and zeros everywhere else, okay? So how do we find the inverse? If you have a matrix, 2 by 2, A, B, C, D, then to find the inverse, you're gonna do 1 over the determinant times, you're going to switch the A and D values. Notice D's here, A's here. B and C are gonna stay in the correct location, or the same location, but you're gonna take the opposites of them. Then what you're gonna do is you're gonna multiply every entry by this 1 over the determinant, and that is the inverse. A couple things to note. A inverse cannot be found by rearrangement because division is not defined for matrices. And then a matrix has no inverse if the determinant is 0. So if you got the determinant as 0, you can't distribute undefined, right? And then if A inverse does exist, it's unique. It's the only inverse, that's the only inverse that exists. That's not the inverse to anything else. Wow, that was hard for me to say. All right, so if we want to, how many do I have to do here? 2, and then there's just mixed practice that you can check with the answer key that I haven't done yet, but I will do it and then put my answers in the answer key so for you to check it. We have 2 to try here to find the inverse, but just to show you that these were inverses of each other, I will do these really quickly. So I will find the inverse of one of these and show you that you get the other. So first you need the determinant. So the determinant, you do these 2 multiplied, which is -1, minus these 2 multiplied, which is -2. So the determinant is 1. All right, that's why this looked so similar to this. It was because the determinant was 1, okay? So I'm gonna do 1 over 1, which is 1, times, switch A and D. So let me erase what I drew all over this. Remember, this is A, B, C, D. So switch A and D, 1, -1. And take the opposites, the other 2, -2, 1. Multiply everything by 1, and you get this matrix, and it's right there. Voila, okay? All right, so let's go down to these 2 to try. I know I'm going all over the place, but I just wanna, circle back here. All right, so this says find the inverse of this matrix, okay? So first thing you wanna do is you wanna find the determinant, okay? So find the determinant of this matrix, 2, -3, -3, 4. You're gonna multiply 2 times 4, which is 8, and you're gonna subtract -3 times -3, which is 9. You get the determinant as -1. So to find the inverse, if we're calling this A, okay? So A inverse is equal to 1 divided by the determinant, which is -1. So we're going to take the opposite of everything when we're done. And then we are going to switch A and D for 2. Take the opposites of the other two. Now, since this is equivalent to -1, I'm going to multiply everything by -1, and we get A inverse is equal to, I don't have to do A inverse, there was never an A, but still. Multiply everything by -1, -4, -3, -3, -2. Now this was a beautiful answer, right? It also says make sure to check that it's true right here, right? That you should get the identity matrix, okay? But that's a beautiful answer there. How can this not be beautiful if the determinant was anything other than, and I shouldn't say anything other than 1, but let's say it was 1/7, and I had to multiply all those by 1/7. Then it would be 4/7, 3/7, 3/7, 2/7. Not pretty, but not difficult to do. All right, let's check to make sure it's right, and then you can pause the video and try the last one. Actually, no, we'll just do the last one together. You'll see why. So let's try to see if this works. So you don't have to do it both ways, but you can. Okay, I'm just going to do it one way. 2, -3, -3, 4. And then my matrix I got was -4, -3, -3, -2. All right, I should get a 2 by 2. That's 1, 0, 0, 1. Row 1 times column 1, right? Row 1 times column 1. That is -8 plus 9. Sorry, minus 9. No, yes, -8. Okay, let's write down our work so that I don't get lost. -8 plus, and then -3 times -3 is 9. That's the 1. Okay. And then row 1 times column 2, that is -6 plus 6. That's my 0. Row 2 times column 1, that's 12 plus -12, which is 0. And then lastly, row 2 times column 2, 9 minus 8, which is 1. Whew, I did it. All right, and then you're also supposed to do it vice versa, but this is just checking to make sure we're doing it right. And there's a way to do this all on your calculator without doing any work, which we will see, okay? But I want you to be able to do it by hand also. All right, let's find the determinant first. 41025 is equal to. Multiply 4 times 5, 20, minus 2 times 10, which is 20, which is 0. That means there's no inverse, right? There is no inverse of this because the determinant is 0, and we can't do 1 divided by 0 times anything. Okay, so what I want you to do now is I want you to try these problems on your own, okay? And then I will post the answers in Schoology for you to check yours.